In this video, I'll show you how to use GeoGebra.org to do a confidence interval for one proportion. So go to the website geogebra.org/classic#probability. From the two tabs, there's distribution and statistics. We'll need the statistics tab. I've prepared an example for us to walk through and learn how to click the buttons in GeoGebra. This is from our Sullivan textbook, section 10.2, example number 2 in the learning material. What do you think is more important, to protect the right of Americans to own guns or to control gun ownership? When asked this question, 46%, that seems important, I'm going to highlight it. 46% of all Americans said protecting the right to own guns is more important. The Pew Research Center surveyed 1,267 randomly selected Americans with a bachelor's degree or more and found that 559 believed that protecting the right to own guns is more important. So I'm going to highlight the sample size as well as the 559 people that believe protecting the right to own guns is more important. So the question, does this result suggest that the proportion of Americans with at least a bachelor's degree feel differently than the general American population when it comes to gun control? Use the alpha equals 0.1 level of significance. So that looks also important. Alpha equals 0.01. So I'm going to highlight that. When you are doing a hypothesis test for proportion, there's not going to be that many numbers. There's going to be a significance level, or else you get to choose it yourself. And then there's going to be a number of successes, your sample size, and then a proportion to compare it against. So the idea of a hypothesis test is there's a known quantity for the population, and then you gather data and you either try to refute that old data or maybe confirm that it might possibly be true. So with our data, we're going to go to GeoGebra, and on the Statistics tab, we're going to click the drop-down menu, and instead of z-test of a mean, we're going to go to z-test of a proportion. So what we need to do this hypothesis test is a null hypothesis. This says that the population proportion P is equal to what number? Well, the population proportion may not be explicitly stated, but it says that we know 46% of all Americans said protecting the right to own guns is more important. So this is representing your entire population, the 46%. So we'll put in 0.46 into that box. So make sure you put in a decimal and not a large number like 46, because your math won't come out right. Then we need to choose an alternative hypothesis. So how do we know what to choose? We have to go back to the question and look for keywords like increased, lower than, different, something to show some sort of movement from what we assume to be true. We assumed 46% was true. Let's go back and read. Let's go to the question. Does this result suggest that the proportion of Americans with at least a bachelor's degree feel differently? So there's that keyword, differently than the general American population. So different is a word to show some sort of change. Was it more? Was it less? We don't know. So a not equals or different than equal to is what we'll choose for the alternative hypothesis. If the word had been more than 46% or increased, then we would have chosen this right-tailed test. So right now we have a two-tailed test. Now we need to figure out the number of successes and the sample size. So we know that it says capital N, but really it means sample size. GeoGebra just uses a different symbol than us. So from our survey, we had 559 people who said yes to a certain question. And the sample size was 1,267. All right, so with that, our hypothesized proportion, it's a two-tailed test. The number of successes in the sample size, we have the result for our z-test of a proportion down below. So it repeats what we were testing, z-test of a proportion, the successes, the sample size, and then the last two bits of information are Z and P. So Z stands for your test statistic, and P stands for your p-value. So our z-test statistic is negative 0.3427. In other words, our sample proportion is about 1.3 standard deviations below the mean. So the people who have at least a bachelor's degree, do they agree that protecting the right to own guns is more important? Well, yes, they did say that it was important, but was it far more than 46? Not at all. Was it a little less than 46? Yep. It was 1.3 standard deviations below 0.46. And if we do the math, we can actually look at this percentage. So doing that calculation, it's actually about 44%. So from our sample, 44% said that protecting the rights of gun owners is more important compared to that 46%. And that's why we're getting that negative. So the p-value is finding the area in the tail that is more different than our proportion of 0.46. So our p-value finds the area in the tail. What's the probability that we get a test statistic more extreme than negative 0.13? So we find the area to the left of negative 0.13, and then because there's a two-tailed test back up here, we would also double that number, and that total number is your p-value. So p-value is being reported as the area in the extreme right tail and the extreme left tail if you were to graph this out. So in our hypothesis testing steps, we would set up a hypothesis test. We would see our significance value. Significance level is 0.1, so 10%. We would look at our p-value, and then we'd compare p against our significance level. So you can think of this as if the p-value is low, h naught must go. So is the p-value lower than 0.1? Nope. So it's actually bigger. There's a little phrase, if the p-value is high, h naught must fly. So that's saying that the null hypothesis, we're going to keep it, if you will. So we're not rejecting the null hypothesis. It doesn't mean the null hypothesis is true, because clearly 44% is different than 46, but our sample's just not extreme enough from 46 to toss out the population proportion of 0.46. So our results for the test would say we would not reject H naught. The p-value is just too large. The chances of redoing the sample and getting something more extreme are pretty common. That's about 18%. So if we were to sample the same number of people again, there's a good chance that we would get something more extreme, which means that the number we currently got is not very extreme. So to interpret this in a sentence, we would say, there is not enough evidence to reject the null hypothesis that 46% of Americans with at least a bachelor's degree feel that protecting the right to own guns is more important. And then we'd report the p-value of p equals 0.1794. So there you go. That's how to do a hypothesis test using GeoGebra for one proportion.